And welcome back to Psychology 303, the analysis of everyday behavior. This is Dr. Wendy Williams, and I'm going to be talking about Chapter 4. Again, this is lecture for Chapter 4B, Schedules of Reinforcement. So I want to talk a little bit about schedules of reinforcement. When we usually talk about the different kinds of consequences like reinforcement and punishment, we usually talk in terms of every behavior leads to a consequence. And that's not actually accurate. Sometimes that's true, but most of the time, not every behavior results in a reinforcer. When it does, occasionally it does, and when it does, it's called continuous reinforcement, or it's abbreviated CRF. And there are cases where continuous reinforcement occurs. The best example I can think of are things like the steering wheel on your car has a one-to-one relationship with the tires on your car, hopefully, so that when you turn your wheel a certain amount to the right, the wheels on your car turn to the right and the car moves to the right. And so there's kind of a one-to-one relationship. The turning of the wheel has a consequence that the car goes in a certain direction. But the truth is, not every behavior is like that. We work a lot before reinforcers are delivered most of the time. We have to engage in a lot of behavior before we actually earn a reinforcer. And how you schedule the delivery of a reinforcer will have a direct influence on how hard you work and when you rest. So that's true for us when reinforcers are spaced out. The way in which they're spaced out affects our behavior. And when you are working with clients, you're going to discover that the way you arrange your reinforcers can have a direct impact on how and when and where they work hard, work less, and when they don't do anything or they do something else. And it really comes down to the timing of reinforcement that can influence the rate or the frequency of a behavior and the pattern of our behavior as well. So one of the things that we can talk about is we can talk about reinforcers in terms of them being based on either the number of behaviors that have to happen before a reinforcer occurs, or an amount of time that has to pass. And so often we refer to the ratio of behavior to reinforcement. And sometimes reinforcement is based on the number of times that we do things. So things like climbing stairs, the number of times you mow the neighbor's lawn before you get paid, the number of buttons that you can push on a phone before you get connected to a particular person. And so this kind of arrangement is called a ratio schedule. And it's based on the number of times you repeat the behavior or that you do the behavior. And time doesn't really matter. You could, texting is a really good example. The length of your sentence is determined by the number of times you press the buttons. And, but it has to do with pressing the buttons. My daughter and I can text the exact same message, and for me, texting is like typing with my toes. I'm so slow and I have to go back and fix mistakes, but she's very fast. So it's the number of letters typed correctly is the same, but she can do it really fast and I can do it really slow. But in the end, it doesn't matter. The time it takes to type, it doesn't matter. In the end, the same message gets sent. And so this kind of arrangement is called a ratio schedule. It's based on the number of behaviors, and time doesn't matter. At other times, it's the time that is important. These are called interval schedules, and we still have to respond, but when we respond matters. In other words, sometimes we have to wait a certain amount of time before our behavior is effective. So examples might be watching my favorite weekly TV show. I have to wait a whole week before I can turn the TV on and watch my show. And no matter how many times I turn it on, it's not going to be there until I wait until it shows up. The perfect 3-minute egg is a great example. You have to wait it starts to boil, you have to wait 3 minutes before you take it out, or it's not going to be perfect. Your dishwasher. You put all the things in the dishwasher, you load it, you fill it with the soap, you close it, and there's a certain amount of time that it has to run before you can open it to take out your dishes. Your dishwasher is the same way. Baking a cake. is the same way. You mix it, you put it all together, you put it in the oven, you set the timer for 40 minutes. You have to wait the 40 minutes before you can get to your cake. So this kind of arrangement is called an interval schedule. Time here matters a lot, but you also have to respond. There's a special schedule called a time schedule, where it's called a response-independent time schedule, and that's where the reinforcer gets delivered no matter what you're doing. And so we're not going to talk about those. We're going to talk about interval schedules where you have to wait a certain amount of time, and then your response will be effective, but you have to do something. Even with my weekly TV show, I have to push the remote to turn it to the right channel before I can watch the TV show. There's also another way to look at these schedules in terms of whether the requirements are fixed every time you do the behavior, or whether they're variable, whether they can change from one set of behaviors to the next time you do it. In both cases, the number of behaviors or the time that's required can either be fixed and the same every single time, or they can be variable and be different from one time to the next. And when you combine these two characteristics, whether it's behavior-based or time plus behavior-based, and whether it's fixed or variable, actually will produce 4 basic reinforcement schedules. You will have fixed ratios or fixed intervals. Both are fixed schedules. And then you can have variable ratios and variable intervals. They're both variable in nature. So we end up with 4 schedules based on these 2 characteristics. So I want to talk about each of these 4 schedules and talk about their effect on our behavior. So let's start with the fixed ratio schedules. A fixed ratio schedule it's defined as when a reinforcer is delivered after a prescribed number of responses has occurred. So there's a required number of responses, and that number never changes from trial to trial. Every single time you go out, you have to hit that goal. So for example, FedEx delivery guys have to deliver a certain number of packages per day. That's just required for them to get their paycheck. The number of stairs per flight in the psychology building, for example. There are 3 flights of stairs, and each one has 12 or 13 steps, and the number of steps for each flight don't change. You still, if you're going from the first to the second floor, you still have to climb those 12 stairs every single time you go. And what happens typically with fixed ratio schedules is that you tend to get what's called a ratio run. The behavior starts and the behaviors happen really quickly. There's kind of a burst of responding. And you can watch this by looking at the people when they're climbing stairs. Some people will just climb the stairs, but they tend to go faster and faster the closer they get to the floor that their goal is. So they tend to move pretty quickly. And there's some people who, when they get to the stairs, they break into a run and they run up the stairs. And so you get this really fast behavior that happens. So you have this what's called a ratio run. The behaviors happen really, really quick because there's no time limit. The faster you respond, the sooner you get to where you want to go, or the faster you get to your reinforcer. There's no reason to go slow because you're going to get your reinforcer as soon as you're done. Ratio schedules also produce something called a post-reinforcement pause, which means before you start the next series of behaviors, there's usually a little pause. When I work with animals, when they work really, really hard on a task where they have to do a certain number of behaviors, when they come back and I tell them, and it's ready for them to start the next behavior, there's a little pause in their behavior before they start. And some people like to call this procrastination. We see more and larger and longer procrastination when the tasks are really large, when the number of behaviors are big. So when you're looking at big projects, so say you're having to write a 10-page paper. You've written 10-page papers before, you know all the steps, you know all the behaviors. They're pretty much the same. A 10-page paper is pretty much a 10-page paper no matter where you go. And when you find out that you've got a 10-page paper for class, you procrastinate a little bit before you get started, and then you just start plugging away at it. And that's pretty typical for a fixed ratio schedule. Same number of behaviors every time you do the behavior. So let me show you some examples. So the FedEx guy, here's the FedEx guy. He has to deliver a certain amount of packages, and he can't be done until he's done with those packages. Climbing stairs, that's the other example. When you go up the stairs, it's the same number of stairs every single time you climb them. Telephone. When you make a phone call, think of someone in your head. Who is that person? And you always have to dial the same number of numbers to get a hold of that person, and in the right order even. The same sequence in the right order to get to that person every single time you do it. And we usually think, oh, I can dial that person's number really fast because I like that person and I do it often. But it's not just practice. It's the nature of the schedule that makes you want to go fast, because the faster you enter their phone number, the faster you'll get to them on the other end. And then down here in the bottom right-hand corner, apple picking. It's that time of year. Fall's here. My apple tree is heavy with fruit. I need to go out and start picking apples. And here is a young woman. She's picking apples, and she's putting them into a bin. And typically, apple pickers get paid for the number of bags that they fill. And so they tend to take a little break after they dump their apples. They take a little break, and then they get started, and they try to fill them really quick. And then they dump another bag. They take a little break, and then they start the next one. So very, very typical for a fixed ratio schedule pattern. When you put someone in a laboratory, when you put a rat, for example, on a fixed ratio schedule, pressing a bar to earn food, and they have to press the bar a certain number of times before they get a reinforcer. Here, it's 100 responses before they get a reinforcer. So these little, I'm going to use my cursor here, these little sideways hatch marks represent reinforcers. And you'll see that the behavior is fairly steady and on a rapid climb. Then they get a reinforcer, and there's a little pause. And then another rapid climb, a reinforcer, and another pause. And it happens over and over and over again. And that A is pointing to that little pause. That's the post-reinforcement pause. And so they get a reinforcer at 100, at 200, at 300, at 400. And so the slope of this line is fairly steep because you get a lot of responses. It's also true that A, that post-reinforcement pause, gets longer as the response requirement gets higher. Here it's 100, but if we doubled it to 200, they would go from 0 to 200. The post-reinforcement pause would be longer. All right, so let's move on to fixed interval schedules. So in this case, again, we have a fixed schedule, but now the reinforcer is delivered following the first behavior after a certain amount of time, after a prescribed period of time has elapsed. And so here we have a time period that doesn't change from trial to trial, but there's a delay. You have to wait a certain amount of time. So my favorite TV show is an example of having to wait a week before I get to see my favorite TV show. Weekly exams. We're doing exams in my class on a weekly basis, and so you have to wait a certain amount of time before the test opens on Friday. And so it's always the same every week before you can take your test. A 3-minute egg. You can't have a 3-minute egg. You have to wait the 3 minutes before you get to your egg. So, and what this does to behavior, unlike this is what we call a step function. They kind of go up and a step, up and a step, up and a step. Unlike the fixed ratio, the fixed interval produces what we call a scallop pattern. And I don't mean like scallop like the food, like the seafood, but rather a scallop pattern like the bottom of your grandmother's curtains. And the peak in responding happens at the moment that the interval elapses. So you get the most responding right before the moment when the reinforcer should be delivered. So let me give you, so here are some examples. My favorite TV show, Bob's Burgers, that's our family's favorite TV show. Your paycheck, how many of you get paid every 2 weeks or every 15 days or whatever it is on the same pattern all the time? Your soft-boiled egg has to be exactly 3 minutes in order to be soft-boiled. If it's less than 3, it's not going to be cooked, and if it's more than 3, it'll be hard-boiled. And for women in the class, Birth control pills are on a fixed pattern where you take pills for the same amount of time. You have to take 21 pills before you get to the placebo pill. In this case, it may not be considered a reinforcer. It might be a punisher, but you get the basic idea. And what happens is you get this fixed interval scallop pattern that looks kind of like the edge of a curtain, where behavior is very slow to get started. There's really no reinforcers for responding early. You can turn on the TV as many times as you want on Thursday, but if your show doesn't come on until Saturday, you're not going to get reinforced with your favorite TV show. So you have to, what you'll see is here I'm going to use my cursor, you'll see a very low amount of responding early in the interval, and as you get closer and closer to the time when the interval elapses, you see a huge increase, a rapid increase in behavior followed by that reinforcer at that moment. So here the reinforcers are being delivered every 5 minutes. And so every 5 minutes, the first 3 minutes, they're not doing very much. And then as they keep going from 3 minutes to 5, you start to see an increased pattern of the behavior, and then they get the reinforcer. And then again, you get that very slow start. There's really no reason for responding early. And as you get closer and closer to that next 5-minute interval, you start to see it increase a lot. So you get these scallops, whereas with the fixed ratio, you get what look more like steps. Okay. Now, let's move to the variable schedules because these are much more complicated. So let's start with the variable ratio schedule. A variable ratio is delivered after a prescribed number of responses. So there's an average number of responses that are required, but that number changes from trial to trial and it averages around some mean. So for example, a slot machine might be on a variable ratio 30 game program. So it may say, on average, it will pay out every 30 times you play. However, sometimes it'll be less than 30 and sometimes it'll be more. It's averages to that 30, but it doesn't stay at 30 every single time. It's not predictable. You don't know when it's coming. The number of steps from our classroom to the library. You might think, well, it's the same distance, but the number of steps you take could be dependent on a lot of things, like your mood, the shoes that you're wearing, whether you're wearing sandals or tennis shoes or whether you're wearing high heels, could all change the number of steps to the library. It might be about 200 steps, but on average it might be 200, but you never really know exactly how many steps it's going to take. Playing golf. A VR is the average is par. So you have, they tell you what par is on a particular hole. So par is 3. That's the average is 3, but you don't know what it's going to take you to get the hole into the ball into the hole. Door-to-door sales are a good example. You don't know how many doors you have to knock on before you actually make a sale. And so it may average during the day. You might say, well, I had to visit 300 houses before I got 10 sales, but it wasn't exactly 30 houses every single time. And so because of the unpredictable nature of the variable schedule, it produces a very steady, high rate of responding. You get lots of responses at a very high rate that's kind of steady. It's not a burst like in the variable, like in the fixed ratio. It's steadier, so the slope of the line is lower because the number required for reinforcement is not predictable. We don't know exactly when it's coming. So the subject tends to develop a response rate that maximizes reinforcement, but also tries to find a balance with leisure. They don't want to be rushing because they don't know when the next reinforcer is coming. So here are some examples. Up here on the left, sales bonuses. You have to make about a certain amount of sales before you're able to get your bonus, but you don't know exactly how or when that's going to happen. And sometimes they don't even really tell you until the end of the quarter who's in first place. Knocking on doors is a good example. Slot machines are always on variable ratio schedules. In fact, one of my colleagues from graduate school, Dr. Alex Hartle, when he finished grad school, he contacted slot machine companies and said, you need to hire me because I'm an expert in schedules of reinforcement, and I can tell you how to make people spend the most amount of money by putting them on special schedules on your machines. And so he got hired, and he makes big bucks. He lives in Vegas. He's making big bucks ripping people off. He's a good guy. And of course, golf, you never really know exactly. You might know what your average is. What do they call it? Your handicap. You know what your handicap is. So you have an idea of about how well you play. But every game is different, and we never really know how many strokes it's going to take before we get that ball into the hole. When you put people on a variable ratio schedule, remember there's no time requirement. There's no time requirement. It's just the number of behaviors. You get a very high rate, steady rate of behaviors. So like this. You get notice the slope of the line is very steep. There's also no steps, and notice that the reinforcers are coming at staggered intervals. That means the person doesn't know when that's coming. So sometimes it's a lot, sometimes it's a little, but here you've got this variable ratio, and so you get this very steep pattern to their behavior. Variable intervals, on the other hand, excuse me, reinforcer is delivered following the first response after an average amount of time. So remember, the fixed interval, it was always the same amount of time. Now the amount of time changes. And we don't know by how much at any given time. The actual delay changes from trial to trial. From every time you engage in the behavior, it changes a little bit. But it averages around a mean. So boiling water, for example, might be, on average, it might take 3 minutes, but sometimes it'll take a little longer. Sometimes it'll boil a little faster. You know, the ambient air temperature might have an effect. Drying your hair might take an average of 2 minutes, but it kind of depends. Checking your voicemail or checking your email. We don't do it all the time, so we kind of have to wait a little while before we're likely to get a reinforcer. Responding to a crying child, sometimes we respond a little, sometimes we respond immediately, sometimes we respond more slowly. And so all of these are on variable interval schedules. A child cries and cries and cries and cries, but they tend to cry louder and louder and harder the longer they have to wait. So variable intervals tend to produce a steady, moderate response rate because the delay required for each reinforcer is unpredictable. We don't know when the reinforcers. So we tend, again, to develop a response rate that's going to maximize our reinforcement, but also not so fast that we get exhausted. So here's some examples. Fishing is a really good example. We don't know when the fish is coming. Pop quizzes. We don't know when the pop quiz is going to happen, and that's what keeps us studying on a regular basis. It's kind of like when your boss checks your work. You don't know when he's going to come and check your work, so you kind of have to stay on your job, doing your work at a steady pace. Checking your email to see if there's someone there. We don't just keep doing it. We wait a little while and then engage in the behavior. And so when you do that, it also produces a fairly steady rate of responding, but notice how much more shallow and lower the slope of this line. The speed of the behavior is much more slow compared to the variable ratio where it's very, very sharp. So here we get steady responding, but it's because we don't know when they're coming, so we just kind of plug away, and with an interval schedule, we don't tend to respond quite as rapidly as we do with a ratio schedule, because the ratio schedule has no time constraints on it. So, using schedules. All right, so using your knowledge of schedules to gain this kind of behavior that you want is a really good idea. When you understand schedules of reinforcement, you can look at the behavior of your clients or your children and identify what kind of schedule they're on. And that will help you understand maybe what type of schedule it is and what would be a better schedule for them. If you want steady, reliable patterns of behavior, then you want to put them on variable schedules. If you see weird patterns, like lots of behavior and then a pause and lots of behavior and a pause, or if you see them responding very slowly and then gradually increasing with steps or scallops, there could be a fixed ratio or a fixed interval schedule operating, so you want to use your knowledge of these kinds of schedules and their effect on behavior to your advantage and shift them to a variable schedule. Now I'm going to give you an example, a real-world example, and I'm going to have to, I'm going to try and pull up a YouTube and include it in this video. So be patient with me. I'm going to see if I can do this. So the example I want to use comes from my work in zoos, particularly the San Diego Zoo, and it was discovered a few decades ago that zookeepers that fed their animals at regular intervals, so they were on a fixed interval schedule when the animals would be fed, usually twice a day, but at the same time every single day, that the animals developed these odd stereotyped behaviors. Things like pacing and head swaying back and forth and rocking were very common. They're called stereotyped behavior or stereotypies. And what I have here is a video of a polar bear who has been fed at the same time every day and has developed a head swaying stereotypy. So give me a second. I'm going to see if I can't pull this up. Okay, so here's our polar bear. And you'll see him over by that's actually the door where the food is delivered. And you'll see that he walks back and forth in front of that door. And then he sways his head left and right, back and forth, and then he'll go back in and start over. He'll look toward the door. There's a little window in the door, and then he starts his head swaying back and forth as he backs up. And he does this over and over and over again with increasing frequency around the time that he gets fed. The reason a polar bear would adopt this unusual kind of stereotyped behavior pattern comes gradually. It begins with the animal learning the times that the food is delivered. They tend to move over to the direction where the food is delivered. And then those behaviors that happen right before the polar bear is fed are the ones that get strengthened. And so looking up at the window gets strengthened. And then it may be that as the keeper opens the door, it shoos the bear away and the bear starts to move backwards. So you get that backward movement and then the head swing, and then it starts to happen sooner and sooner and sooner before the food's delivered. And so with very little, this can happen very quickly. You can start to get stereotypies in a very short period, like within a month, you can start to get stereotypies in animals if you feed them at the exact same time, particularly predators. So big cats, bears tend to get a lot of stereotypies. And so you can get them in other animals. You can get them in badgers, and I've seen them in badgers. I've seen them in otters. I've seen them in lots of different animals. But one of the best ways, once you pay attention and you realize that they happen at certain times of the day, more than they do any other time, and when they're very fixed and rigid in their behavior patterns, and when food's being delivered, that's when you realize, oh, the animal's on a fixed interval schedule. He's being reinforced at exactly the same time every single day for whatever behavior is happening. And when it's a stereotypy, it strengthens that behavior, makes it stronger and stronger and stronger, making it last longer and longer. So the solution here is to do your observations, doing your ABC observations, and identifying the function of the behavior. This behavior doesn't actually have a real function. It's like a superstitious function. And but this bear has this behavior pattern that he engages in, and it always ends up with him being fed. So he keeps repeating it. And so that would tell me, oh, we need to get that feeding schedule onto a variable feeding schedule. Variable intervals, unpredictable intervals, so that the animal doesn't know when the food is coming. What that will functionally do is it will put this pacing and head swaying behavior on extinction. He'll pace and sway and move his head back and forth, and nothing will happen. Food will never come. And he will very likely be doing something else in the exhibit when the food's delivered. And so you'll start to break that pattern and start strengthening other kinds of behaviors rather than the stereotypy. So you'll be replacing the stereotypy with more naturalistic behavior. So a good example of why you might want to be watching for the current existing schedule and looking to see if there's a better schedule that you can put the individual on. Now, this is just a zookeeper example because this is the kind of stuff that I'm familiar with, but you can get stereotypies in all kinds of populations. You get it in jails and prisons. You get it in daycares. You get it in school settings. You can really get these sort of unhealthy behaviors that come as a result of the way they're being reinforced. So I'm going to stop there, and we'll come back and talk to you a little bit later in 4B about the kinds of variables that affect reinforcement. Have a good day.